Priority queue. What is priority queue? Collection of elements. Each element has a priority of key. Different implementation of a priority queue is possible. Different implementation of priority queue is possible. We'll use heap data structure to implement the priority queue. Queue is not nothing just a row or column. Just think like that. Collection of elements. Collection of elements like what? Like array, stack. Like collection of elements. What is queue? This is queue. Each element has a priority or key. Different implementation of priority queue is possible. We will use heap data structure to implement the priority key. Two kinds of priority queues we know is the mean priority key and max priority. Mean heap means the key value gets the highest priority, and the key value gets the elements with maximum key. Elements with minimum key value gets the highest priority. Elements with maximum key values gets the highest priority. Following are the operation available for a priority queue. Heap. Create a heap with a given set of values. Create a heap. Create. First of all, you have to create a heap. Okay, there is no heap. Heap. What is heap? Okay, next slide we will discuss. Create a heap with a given set of values. Insert an element into the heap. Delete mean or max element from mean or max respectively. Sort the element in ascending or descending order for max and mean heap. Okay. Properties of a heap. What is heap? Heap is at least a complete binary tree. If you saw a complete binary tree in website data structure in data sorted, okay, it's called a heap. Heap is a complete binary tree. Mean heap and a max heap. What is mean heap and what is max heap? Mean heap, the key value of the parent is lower than its children, and max heap, the key value of the parent is higher than its children. Okay, here 5 is 1 left child. Okay, next heap is implemented using an array starting from index 1. Heap is implemented using an array starting from 1, not 0. Okay, heap is in our array we can declare it 0, right? Not here. We will start with 1. Index 1 contains the root. Left child of any node at index p is sorted at index p into 2, and right child of any node as p is sorted at index number is p into 2 plus 1. So the parent node of any child at index c is found at index c by 2. Ceiling function, right? Ceiling or floor function, sorry, floor function. Okay, here 10 is 10 is greater than or less than? Yes, 10. 1 into 2. Why? Because you are declaring this p, so p into 2, p into 2, p is 1, index 1, and we we are doubling it, and 2 into 1 is 2, so this is now our value. Left child into 2, 10. Right child, left child give p into 2, and right child will p into 2 plus 1. Right child will then 1 into 2 plus 1, 3. So index 3 will be 15, right? Index 3 will be 15. And index parent, now we have to change our parent. Our value of 2 2 divided by 2 is 1, and we are taking floor function, right? 2 divided by 2 is 1, and 3 divided by 2 is also 1.5. not this is called floor function. We will take the lower one. Okay, 1.5. If the ceiling function, we will take the 2 1.5, then we will take the 2. Okay, next. Now our parent is 10. Now index change. Index, now what? Index is 2. 2 into 2 is 4. Okay, 4. Index 4. Left child equal to 4. Right child equal to 5. 4 entering 10 in our child parent 10. Okay, here 10 is parent and 20 is 10 is parent, 20 is child. Okay, left child we are putting here left child, not right child. Right child will be 35, right? Yeah, 2 into 2 plus 1, 5, index 5. 1 index 2, 3, 4, 5. Okay, now I have to change our parent. Okay, here parent here 4 divided by 2 is 2, and 5 divided by 2 is 2. So index 2 will be our parent, next parent. Okay, next then our left child will be shift, and right child also be shift. Next 3, if it is 3, then 3 into 2, 1, 2, 3, right? We know previously is index 1, index 2, index 3, right? Then I have to switch it. 3 into 2 into 6. 6 index will go to 15s and 7 will go to 45. 30, 45, 7. Our parent will now change. 6 divided by 2 is 3, 7 divided by 2 is 3. Now it is 4. Okay, 1, 2, 3, 4. 4 is or 20. 20 is our now next parent. So our left child and right child is what? Left child is 4 into 2 in 8. Here is 8 index 25. As 32 is index 9. Next will be 30, 35 is our parent. 8 divided by 4. 4 equal to 5. 5. So 5 into 2 into 10. 5 into 10, index 10 is 38, 30 will go to 35, 30, 10, 11 will go to 40, index 40, and next 30 will be our next parent, and our 6 into 12 index will go to 43, will go to 30 parents. This is our heap. Okay, if you want to see again, let's see. Here is one left child, right child. Here is a concept of parent. Okay. 2. Why is 2? Because here is 2 and 3 dividing by 2. Okay, that's why this is 1. This index is 1. Okay, so parent concept is gone now. Okay, now starting from left child. Okay, 2. Our index is switching. Okay, 2 now 4. 2 into 2 plus 4 5. 4 divided by 2 is 2 2. So our parent should be 2. Index 2. That's why 10. Then it disappear. Okay, so parent we don't have to 4 5, we have to put our value in our 10 20 35. Okay, then 15. Okay, that disappear. Okay, let's change 2 3 2 3. Okay, change. Parent concept is totally gone. First of all, there wasn't any concept called parent. Okay, left child, right child, and then parents come. Okay, same left child, right child, and parent. Same thing again and again and again and again. We are changing our parent to left and right child index number, and we are putting our values. Okay, if there are n elements in a heap, there are n by 2 parents index from 1 to n by 2. Leaf nodes are index from n by 2 plus 1 to n. Okay, creating a heap. If you want to create a heap, this is the format. So properties of heap is like that. We will discuss in next next video how to create a heap and so on.